Ever wonder why some USB chargers seem to take forever to charge your devices, while other chargers seem to be quite fast? Well, it's not the charger, it's the cable. And to prove it, we're going to use a USB voltmeter. This is actually a volt amp meter. They're very inexpensive. So let's plug it in and we'll see what we get. Here's where I got mine. Obviously, I got the silver one. Very, very useful. Okay, I've got the meter connected. I'll turn on the power strip. Let's see what we get. It's showing less than 4.9 volts. And the current is all over the place. Anywhere from 1/10 of an amp to 1/3 of an amp. 4.85 volts. Current is all over the place. The meter is supposed to flip back and forth between volts and amps, but the amp should be steady and the volts should be steady. It's certainly not steady here. 1/3 of an amp tops. Not very good performance, surprisingly bad. Okay, let's switch this cable. I've disconnected the black OEM cable, replaced it with a white cable. This one came from a tactical flashlight, so it's the cable from that charger. Alright, turn on the power strip. What are we going to get? 4.94 volts, that's higher than we saw before. A very steady 1/4 of an amp, 0.27 amps. Back to a steady 4.94 volts. Wow, look how steady this charging behavior is. So, is it any wonder that things would charge a little faster using this cable? But this thin white cable is not the best that we can do. Let's try an even thicker one. Okay, this will be test 3. Now the cable I have connected is from a Nintendo device, and for comparison purposes I've got this white cable from the tactical flashlight charger here. Can you see how much thinner the white cable is than this Nintendo cable? Is that going to make any difference? It's quite a bit thinner. Well, I think we're in for a surprise. I'll turn on the power strip. .46 amps charging current, 5 volts, same Pantech charger. 0.65 amps charging current. Is it any wonder that the Nintendo charger is 3 or 4 times faster than this Pantech had been? Look at this now. 5 volts. We're not falling below that. 0.83 amps charging current. Any wonder that this is so much faster? So why is this important? Because in a grid down situation, would you rather take 5 hours to charge just one device? Or would you rather charge 5 devices in that 5 hours of bright sunlight? Well, if that's what you want to do, you're going to need to replace those slow charging cables with something like this. Here's one I picked up from a local retailer. It was only $4. It's very fast. It's just as fast as that Nintendo cable, and that's the answer to the problem. So we want to maximize the sun while it's out. We want to charge things as fast as possible. Who wants to wait 5 hours or all afternoon to charge a phone or a tablet? That's crazy. $4, good investment, good upgrade for your solar power backup system. So I hope you're as surprised by this as I was. I didn't think the difference would be that great, but what a difference that thicker cable makes. Live and learn. Thanks for watching.